You can have the perfect CPU, GPU, and RAM, but choose the wrong motherboard, and your entire PC build can become a problem. Many builders assume a flagship price tag translates into higher gaming frame rates, but spending $500 on a motherboard rarely increases performance. The motherboard serves as the central infrastructure of your system. It directs data between every component while dictating which processors you can install and how much power those components can safely draw. Finding the right board means matching the connectivity to your specific hardware list. If you buy features you never plug anything into, you are effectively paying a tax on performance you aren't using. Identifying the correct model involves evaluating the CPU platform, memory requirements, and power delivery in a specific sequence. This process ensures your expensive components are never bottlenecked or rendered completely unusable by the hardware holding them together. Start with the CPU socket and platform. This physical interface determines which processors will actually function in the build. You must match the exact socket generation. Older or mismatched processors will physically clash with the pins and refuse to drop into the board. The same strict hardware lock applies to your system memory. The current market is split between two distinct generations, DDR4 and DDR5. These modules are not interchangeable. As you can see, the physical notch is in a different location on each stick, making it impossible to install the wrong generation into a motherboard slot. Once the socket and memory are settled, you have to choose a physical form factor: standard ATX, Micro-ATX, or the compact Mini-ITX. Shrinking the form factor limits your expansion. While ATX boards offer multiple slots for extra cards, moving to Mini-ITX usually cuts your available RAM slots in half and removes all but one PCIe lane. These are the hardest filters in a build. Selecting a dead-end platform or an incompatible size will force you to return your components and restart the entire process. Next is the chipset. This is the motherboard's traffic controller, managing the flow of data between the processor, your high-speed storage, and the rear ports. Chipset tiers range from entry-level to enthusiast. Premium tiers provide more lanes for multiple fast hard drives and graphics cards, while entry-level options restrict those lanes to save on cost. Surrounding the CPU socket is the VRM, or Voltage Regulator Module. This system cleans the raw power from your power supply and delivers a precise, stable voltage to the processor. High-end processors require robust VRMs and cooling to sustain maximum performance. Without it, the CPU throttles speed to prevent overheating. However, a standard gaming processor draws little power. Pairing a mid-range CPU with an extreme overclocking board wastes money on unutilized power components. Buying an enthusiast chipset for a mid-range locked CPU is a common way to inflate a budget with features that provide no tangible benefit to the user. Your graphics card will occupy the primary PCIe slot. On modern boards, this is the reinforced high-speed lane wired directly to the CPU. If you plan to add capture cards or dedicated audio gear later, check for additional PCIe slots further down the board to ensure you have the physical space to expand. You should also verify the number of available M.2 slots to ensure you have enough room for your NVMe solid-state drives. Check the manual for lane sharing. On many designs, using a specific M.2 slot will automatically disable certain SATA ports or reduce the bandwidth available to other expansion slots. While checking the layout, note the number of RAM slots and the maximum supported capacity to determine the ceiling for future memory upgrades. The rear I/O panel determines your daily physical connectivity. This is where you verify the number of USB-C ports, the speed of the Ethernet port, and whether the board includes built-in Wi-Fi and Bluetooth. Choose connectivity based on your actual environment. If your PC will be permanently connected to a router via Ethernet, you can save money by choosing a model without built-in Wi-Fi. Before making a final choice, consult the manufacturer's CPU support list. This confirms your processor will function with the board's out-of-the-box BIOS version. Selecting a board with precise connectivity matching your workflow eliminates the need for external adapters and prevents immediate hardware bottlenecks. The motherboard defines the lifespan of your PC. It sets the limit on how much faster your storage, memory, and graphics can get in the coming years. Mistakes often involve simple oversights: picking the wrong CPU socket, buying the wrong generation of RAM, or lacking enough M.2 storage slots. Other builders find themselves without enough expansion slots for a capture card, missing Wi-Fi when they can't reach an Ethernet port, or realizing their BIOS lacks CPU support. Future-proofing requires enough lane capacity to grow, which means identifying which marketing features to ignore and which connectivity options are mandatory for your work. Consider a standard gaming build in an ATX case: a modern CPU, one graphics card, 32 GB of RAM, 2 NVMe drives, and Wi-Fi. These requirements point toward a mid-range B-series ATX board, providing DDR5 support, 2 M2 slots, and Wi-Fi. The best buying formula is CPU compatibility, chipset, memory, form factor, power delivery, expansion, storage, connectivity, BIOS, and price. Let's test your retention with a quick motherboard challenge. You're building a PC with a modern CPU, DDR5 RAM, 1 GPU, 2 NVMe SSDs, and Wi-Fi. What should you check first when choosing? The answer is B, CPU compatibility and platform. Tell us in the comments how many of these motherboard factors you were already checking. If you enjoy simple explanations of PC hardware, subscribe to All About Tech for more.